Hey guys, welcome back, and we're picking up right where we left off. We're going to be developing some more on Solana with Rust. And now in this video, we're actually going to be talking about how the Solana accounts sort of like ecosystem works here. I've got this diagram here that kind of explains what we're going to do in this exercise. Now, this might look a little confusing, but we'll come back to it as we code and it'll make a lot more sense. But basically what you need to know is smart contracts on Solana, like we talked about last video, are called programs. And as you saw in the Hello Solana video, we created a program.sol, and that gets deployed on the Solana network. And this is a little example of what it looks like when a program's deployed. If we have a program that's going to, let's say, modify some data on any kind of account on the Solana network, this is sort of how that process looks. So we use our local key pair with Solana keygen, like that public-private key that we created locally with the CLI. We write our Rust code, and then we deploy that program on the network using a transaction. And that's just a deployment transaction, right? Cargo build BPF. So once that's out there, and we've deployed it using the Solana CLI, it's sitting there waiting. And that's actually called a executable account. And it's sitting out there and it's ready to go, waiting for you to come up and do business with it. So then we did exactly that, and we created another account with our Solana Web3 API, and we went and transacted with our program. But what we didn't really get into was kind of how that data management works. And so in this video, that's exactly what we're going to see. So I am going to fast forward quite a bit in this video because there's a little bit of code to get through in order to pull this off, but we're definitely going to go through each thing one by one. So to start, I created a package JSON that's pretty much the same as in the last video. I've got some more dependencies in here, and a lot of this stuff is actually taken from Solana's Hello World example. So if you need a little bit extra look at like how some of this stuff works, it looks like this. I'll put the link in the description. They have an example for C and for Rust and a Typescript client. So this is actually really helpful too. But anyway, so this is a package JSON. And like you saw in the last video, we have a few scripts here. I actually wrote this like CI/CD script here just to kind of make life easier for us. So you can see like we're packaging in like cargo build BPF. We've got cargo clean. We've got, this is how we're going to automatically take down all of our Solana programs, like stuff like that. So if you're interested in like what this thing does, or if you want to just like pull it down, check out the GitHub. But all this is really going to do is allow us to just kind of like quickly do stuff with our repo. So you don't have to like watch me painstakingly do all of these one by one. Anyway, as you can see from the top here, we're going to write two programs, sum and square. And I've titled this repo math stuff because we're just going to do some simple like math equations here. And these are both going to be our Rust programs. So I'm going to go ahead and open a terminal. And when I do that, I'm of course going to move into source. And I'm going to do our cargo new lib sum. And once that's created, I'm going to do another one for square. Now we can close this out. And I'm also going to create our client. Excellent. So if we look at our code from the last video, if we look at this Hello Solana example that we were looking at, we remember here from our lib.rs file, this is really all we had in here, right? Like Hello Solana, that was really it. So I'm going to copy this back in there. And so I've actually gone ahead and set up our cargo tomls as well. You can see we're using the Solana, same stuff that we saw before. We also added Borscht, so we can do that serialization that we mentioned before. And now let's build on what we did last time. So last time we just output this log message, and that was all we did. So we didn't do any kind of like change of state or like any kind of like transactional operation. All we did was just execute some code, right? Like the basic hello world. So how this actually works, like we talked about, is we're going to pass in the program ID, which is going to be this program itself. Then we're going to pass in any of the accounts that we want to transact with. that the program should be transacting with. And then there's particular instructions that you can add. Now in this video, we're going to omit the instructions again, but I promise we will get to that. We're building up to it. But in this video here, we're going to talk about what's happening to these accounts and how they store data. So I just made this thing a little bit bigger for you guys. But we're going to go ahead and add a schema. First things first. And that's just going to be a struct. So before I do that, I want to just quickly add our Borscht dependencies up to the use statement. And I want to just pop these new items in here that we're going to be using. Just a couple quick things. And once we've done that, then what we're going to do is add our struct. So we're going to do pub struct math stuff sum. We're going to make a public field of sum. And of course, we have to remember to add our annotations. So those Borscht serialized and deserialized guys, they're going in there. And now this will be allowed to be serialized and deserialized using Borscht, which is exactly what we need for Solana. So entry point, same as we saw before in the last video. And now let's blow away our hello world statement. And here, what I'm going to actually do is I'm going to copy directly from that hello world example that I showed on screen. This is what Solana recommends you do at the start of your program. And I'll tell you why. So first of all, it says iterating accounts is safer than indexing. So instead of trying to get from the list of accounts, as you can see, this is a list up here. Rather than try to get the first one, number 0 or whatever, it's actually safer to go with iter and then use this next account info method. They wrote this stuff up for that reason, to be a little bit more safe. So that's what they recommend you do. And they also want you to be checking to make sure that the account is owned by the program ID. Now this is pretty important here. This is a big Solana rule, and we've touched on it before. The account that you want to transact with this program must be owned by the program ID. Now, that's okay if you don't understand what that really means right now, but when we write out our Typescript client, you'll see exactly what that means. But anyway, so as long as that checks out, we're not going to get this error, and we're going to move forward with our program here. And just to help us get an understanding of what's going on inside, I'm going to actually add some verbose output here with some of those message macros here. So I'll add these verbose outputs, and all I've really done is I want to display some of the fields. And if you look, these fields are really just account info. So this right here is going to be an account info type. And if you just hold Control and click in Visual Studio Code, you can see all the different fields that come with that struct. So we're just going to take a look at some of those. And then below that, we're going to actually write the logic of what our program is supposed to do. And that's going to, of course, be adding some kind of sum, right? Creating some kind of sum. So we're going to just add 1 every time. So every time we run this program, you're going to add 1 to the sum. And then that's going to be represented, of course, by the struct that we created up here. Okay? Now the logic to do that looks like this. So that is really all it takes right there. So this Borscht type comes with a pre-built method here called try from slice. And as you configure, that's just going to be a string slice representation of the bytes that make up this schema. So it's going to attempt to deserialize this slice into a math stuff sum struct. And then we'll be able to add 1 to it and reserialize it back into Borscht. And then, of course, we're able to capture that value while it's in here in our program, and we're able to spit it out to the user. So that's really it. That's all it takes, guys. That's how we write our smart contract that's going to, of course, be doing, just a simple summation. So I'll save that. And now I'm just going to copy this into Square. And as you can kind of probably predict, all we're really going to do is instead say squaring value. And then up here, we're going to just change this just so we don't get confused. All right, so our 2 programs are totally done. And now we can deploy these on the network like we saw before. But before we do, we need to write our TypeScript client. So Let's go ahead and do that. So I skipped ahead here and I went ahead and created these 4 TypeScript files. And math is really going to be our main one, and we'll come back to that, but we'll start with util. So as you can see, we just have this one util method that's going to just be to create a key pair from a file. And all that's really going to do is it's going to take a file path to a JSON key pair, and it's going to turn it into a key pair object from the Solana Web 3. You can see that we've got this key pair object here. So that'll come in handy. And then I also went ahead and did some of the imports here because honestly, I figured you guys didn't want to see me mess with bringing all those in. So those are already pre-configured for us. And we're going to start with this math class here because these two are going to just be the drivers, right? We're going to have sum, and if you look at package JSON, we're going to have sum drive our sum example and square drive our square example, okay? Self-explanatory. So math.typescript is really going to be the one that we're going to focus on here. Now, there's a couple things we have to do in order to make this thing happen, right? To be able to do business with our programs on Solana. So the first thing we want to do is we want to get the key pair from our local config. And that's obviously going to be just the path to our config file. I'm going to be using WSL2 on Windows, so just make sure that this lines up with what you're trying to get at. And then we've also just added these fields right here because these are going to be the things that are going to be super important. So the first is a connection to the network, and then we'll talk about these as we go. And then I obviously just saved this path here as a constant because we're going to need that, of course. We want to know where our programs are. And obviously that's just going to be our connection right there. And here we're obviously just going to load in our key pair like we talked about. So here's that create key pair from file. We're using the YAML config that we got from our Solana config path. And then we've just got some output here to let us know that it was successful. And here we're going to just be grabbing the program that we intend to ping or we intend to transact with. So as you can see, we're going to use this method here. We're going to be using create with seed. Now, the reason that we're doing this is because the seed allows us to create this key with a predictable seed value, but it's also, as you notice, that program ID is in there. This is going to make the program ID the owner of this account that we create, which is exactly what we said we needed in order to be able to do any kind of business with it. And then our seed is just going to be test 1 here, of course, and that's just going to be something that we're going to go in and change. And I'll show you guys exactly what happens when we change this account information. So down here, if it doesn't exist, right, of course, we're going to create it. If it does, we're just going to use it. And that's why we create the key separate up here. So now that that's all set, the last thing we have to do is just ping our program. So as you can see, we're doing this like we did before. We're going to use another just 0 for the data because we're not using any data here again. So definitely familiar here. And then the last step here, of course, I'm just going to copy this last one in outright, because we're just going to run the example. This is going to be like sort of our main method here. All right, cool. So now that this is done, our math TS is completely done. Let's quickly recap here, and then we'll go trigger this thing. So connect to the DevNet, get the local key pair, that same key pair that we used to deploy the programs, mind you. Then we get the targeted program that we want to be hitting. And then we configure a client account. And now this is really important because the client account is going to be the account that stores data. The client account is the data account. And so when we create this account using this test1 seed, this account is actually going to go hit our program, and the program is going to change the state of our account. And that's super, super important. And that's why you'll see as we go here and create our other stuff, like let's go to some TS and let's just like paste it in here. So as you can see, we just threw in our main trigger, of course, and our main method. And we need to pass in the program name, right? Because that's what we said at our bottom, like sort of main method here. And we also need the space size of the program. And now we didn't really talk about that yet. So like, what is this? Well, this is going to be just the size in bytes of what we need to store in this account. So in this case, we saw that we created a schema down in the Rust program down here. You know, we saw this schema here, and this is what the program is expecting on the network. So we have to kind of like mimic this with our account as well. And I'm not going to type all of it out one at a time. I'll just copy it in, but that looks like this. Now, as you can see, we're creating the exact same struct. This time it's a class here, right? And then we use this map right here to turn it into a struct. And that way it's going to match. And you can see our field name is the same. And we have a U32. That's exactly what we did here. Okay? And so that is how we actually can create the byte representation. And then we do the serialization and we get the length. Right, so these three steps here turn a TypeScript class into a struct, into a serialized set of bytes, and then we take the length so we can get the size. Okay, so now we can make sure that everything's going to line up. So this is enough to trigger our sum function here, and I'm going to go ahead and just copy in the one for square because it's exactly the same. And now that that's done, let's finally run this thing. So just a quick nod to this script here. If I do this full reset and build, we're going to wipe all the node modules. We're going to drop any programs that are running on Solana. We're going to remove any program SO files. And then we're going to build each of them and deploy them. And then we're going to prepare our client and we'll show the programs last. And then we'll trigger them manually. Okay? So let's go ahead and do that. All right, so now you can see that our programs are just chilling out here on the Solana network, and there's both of them right there. There's sum and square, and if we scroll back up, we can see which is which. Square was built second, and you can see the program ID for square is right here. It starts with the 8. So this one is going to be our sum, and we're going to try sum first. So I've just got this like Solana logs grep command. If you saw the last video, you know what this is going to do. So we're going to start that off. And then we're just going to do npm run example sum. And now as you can see, we're going to get all of our outputs here like we wrote it. Connect to the DevNet. And now let's see what's going on here, right? So on the left side here, local account loaded successfully. And there's the address of my local account that I'm using to deploy this stuff. I use that same account to deploy the programs. I used it to build that address with the seed. And here's the program ID for the sum. And then down here, as we wrote this little message out, this is the generated address we got from that seed. And so if we look at this address, right, like let's close this into the corner and let's open up another terminal. And let's just do Solana account, and I'll copy this and we'll take a look at this. So as you can see, the balance is 1 sol. And you can see that the owner here is the program ID. Bingo. And just for the record, program ID is just the public key of the executable account that is the program. And you can see that this account here is not executable, but it has a length of a certain amount of bytes, which means it's storing data. So if we run this thing again, npm run example sum, we're going to use the same exact address again because the seed is the same. We're using the same local address. It's all the same. And let's watch our output up here in the logs. Classic Solana DevNet errors. There we go. But unfortunately, our log thing wasn't on. One more time, ladies and gentlemen. One more time. Just an FYI, the DevNet can be a little spotty because these guys are constantly working on the network. But now that we get a successful run, we missed that last one, but you can see that our current sum is now 3. And if we keep running this, obviously you know what's going to happen. It's going to keep incrementing. But this is what I was talking about with the seed. We just showed that this thing has its own data being stored. So what happens if we go ahead and we change this seed from test 1 to, I don't know, let's say test 2. And just so you know, I commented out the airdrop here because we're probably not going to need any more sol. But yeah, so let's just change that to test 2 and see what that does to the resulting account. And I ran this a couple more times off screen just to make sure we weren't having any more errors. So now if we run the example with that test 2 instead, you can see that our account is a little bit different, right? Like here's our new address right here. It's this 9x instead of EJ. And check out the output. The sum goes back to 1, right? And that's because we've just introduced a brand new account with its own data that's separate from the one we were running. And so just, you know, just for completion's sake, let's go ahead and look up this new account. It's going to look pretty much the same on this command right here. But the idea is these have their own separate data stores. They're storing their own individual states separately. And so if we run that again, but we flip back to test 1, and just so you know, I had this at a sum of 4, sum of 5 actually, sorry, right before we switched. So let's do it again. We're back at test 1. We should see on here, sum is now 6. And that's exactly what we see. So, bingo. That is it right there. That's how you do it. That's how we ping a program and we tell it to transact and change the state of a Solana account. And back to this diagram here, that's what I was trying to get at earlier in this video, is we deploy our Rust program and that's sitting on the network. And then we create an account using the TypeScript code, using that API. And then another account is sitting on the network in a different location. And our client using the API, that final step right down here, that ping step, all this ping really does, and all of these instructions really do that are coming in, is just tell the program that lives on Solana, hey, I want you to do whatever business logic is inside of you on this. And it's really just pointing one thing on the Solana network to another. And that's really all it is.